Good morning, students. I would like to introduce the main concepts of section 10.3. If you will please open up your textbook to page number 715, I would like to explain the theorems. And the first thing I have here is a picture which shows a number of circles, and I'd like to talk about the theorems in relation to the circles that I've pictured. Over here, I have the chord AB. It goes from here to here. And then I have another chord that goes from C to D. Remember that a chord is a segment which touches the circle in two places. It touches the circumference of the circle. So first of all, what I did is I drew some chords that were equal. Let's imagine that chord AB is the same length as the chord CD. Notice that when I label these, as I'm just outlining the chord AB and the chord CD, I put a segment symbol above them. And I'm telling you to begin with, therefore, that I've drawn two chords such that their lengths are the same. But just below that, you see what I've done is I've also showed the arc. Now the arc, of course, is the distance along the perimeter, and the law here, theorem number 10.2, is that if the chords are equal, if the distance from A to B equals the distance from C to D, then the arcs along the perimeter have to be the same length too. So in other words, if the distance from A to B is equal, then that implies that the distance around the circle here is the same distance as around the circle here. Okay? Now, this statement can be thought of also conversely. Also then, if the arcs are equal, their chords are equal. So if arcs are equal, chords are equal, and if chords are equal, then arcs are equal. So what I've just done is covered for you section or theorem 10.2 on page 715. And also, this is explained for you on page number, the top of 716. I'm moving on now to theorem 10.3. Section or theorem 10.3 says that if the diameters of a circle is perpendicular to a chord, then it bisects the chord and it bisects its arc. So in my next picture here, I have a circle which is labeled C. It's labeled C, which implies that the circle itself is the circle C. And from this center C, what I did is I drew a line which hits the chord AB. So I drew this line right here, and it hits the chord AB. Now this theorem says that if you have a line from the center of a circle that hits a chord at 90 degrees, then it bisects the chord. So I've written this down here. If the angle CDA or the angle CDB is 90, that implies that the line CD must bisect AB. It cuts it in half, in other words. Now this can be thought of in a couple different ways. It's also true, for example, if AD equals DB, if, in other words, AB is bisected by the segment CD, then CD must be at 90 degrees. So if 90, then it's the bisector. If it's the bisector, then it's 90. Okay? So those are some things that we're going to be working with as we do our assignment today. Another statement that I want to introduce before I go through some problems, some demonstration problems, is the following.